I read to you Foundation Level Extension Syllabus, Agile Tester, version 2014. Provided by International Software Testing Qualifications Board, ISTQB. Read to you by Gameel. Chapter 1, Agile Software Development. 1.1, The Fundamentals of Agile Software Development. A tester on an Agile project will work differently than one working on a traditional project. Testers must understand the values and principles that underpin Agile projects, and how testers are an integral part of a whole team approach, together with developers and business representatives. The members in an Agile project communicate with each other early and frequently, which helps with removing defects early and developing a quality product. 1.1.1 Agile Software Development and the Agile Manifesto. In 2001, a group of individuals representing the most widely used lightweight software development methodologies agreed on a common set of values and principles which became known as the Manifesto for Agile Software Development, or the Agile Manifesto. The Agile Manifesto contains 4 statements of values: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. The Agile Manifesto argues that although the concepts on the right have value, those on the left have greater value. Individuals and interactions. Agile development is very people-centered. Teams of people build software, and it is through continuous communication and interaction, rather than a reliance on tools or processes, that teams can work most effectively. Working software. From a customer perspective, working software is much more useful and valuable than overly detailed documentation, and it provides an opportunity to give the development team rapid feedback. In addition, because working software, albeit with reduced functionality, is available much earlier in the development lifecycle, Agile development can confer significant time to market advantage. Agile development is therefore especially useful in rapidly changing business environments, where the problems and/or solutions are unclear, or where the business wishes to innovate in new problem domains. Customer collaboration. Customers often find great difficulty in specifying the system that they require. Collaborating directly with the customer improves the likelihood of understanding exactly what the customer requires. While having contracts with customers may be important, working in regular and close collaboration with them is likely to bring more success to the project. Responding to change. Change is inevitable in software projects. The environment in which the business operates, legislation, competitor activity, technology advances, and other factors can have major influences on the project and its objectives. These factors must be accommodated by the development process. As such, having flexibility in work practices to embrace change is more important than simply adhering rigidly to a plan. Principles. The core Agile Manifesto values are captured in 12 principles. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Welcome changing requirements. Even late in development, Agile processes harness change for the customer's competitive advantage. Deliver working software frequently, at intervals of between a few weeks to a few months, with a preference to the shorter timescale. Business people and developers must work together daily throughout the project. Build projects around motivated individuals, give them the environment and support they need, and trust them to get the job done. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Working software is the primary measure of progress. Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Continuous attention to technical excellence and good design enhances agility. Simplicity, the art of maximizing the amount of work not done, is essential. The best architectures, requirements, and designs emerge from self-organizing teams. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. The different Agile methodologies provide perspective practices to put these values and principles into action. 1.1.2 Whole Team Approach. The whole team approach means involving everyone with the knowledge and skills necessary to ensure project success. The team includes representatives from the customer and other business stakeholders who determine product features. The team should be relatively small. Successful teams have been observed with as few as 3 people and as many as 9. Ideally, the whole team shares the same workspace, as co-location strongly facilitates communication and interaction. The whole team approach is supported through the daily stand-up meetings, see section 2.2.1, involving all members of the team, where work progress is communicated and any impediments to progress are highlighted. The whole team approach promotes more effective and efficient team dynamics. The use of a whole team approach to product development is one of the main benefits of Agile development. Its benefits include enhancing communication and collaboration within the team, enabling the various skill sets within the team to be leveraged to the benefit of the project, making quality everyone's responsibility. The whole team is responsible for quality in Agile projects. The essence of the whole team approach lies in the testers, developers, and the business representatives working together in every step of the development process. Testers will work closely with both developers and business representatives to ensure that the desired quality levels are achieved. This includes supporting and collaborating with business representatives to help them create suitable acceptance tests. Working with developers to agree on the testing strategy and deciding on test automation approaches. Testers can thus transfer and extend testing knowledge to other team members and influence the development of the product. The whole team is involved in any consultations or meetings in which product features are presented, analyzed, or estimated. The concept of involving testers, developers, and business representatives in all feature discussions is known as the power of 3. 1.1.3 Early and frequent feedback. Agile projects have short iterations, enabling the project team to receive early and continuous feedback on product quality throughout the development lifecycle. One way to provide rapid feedback is by continuous integration. See section 1.2.4. When sequential development approaches are used, the customer often does not see the product until the project is nearly completed. At that point, it is often too late for the development team to effectively address any issues the customers may have. By getting frequent customer feedback as the project progresses, Agile teams can incorporate most new changes into the product development process. Early and frequent feedback helps the team focus on the features with the highest business value or associated risk, and these are delivered to the customer first. It also helps manage the team better since the capability of the team is transparent to everyone. For example, how much work can we do in a sprint or iteration. What could help us go faster? What is preventing us from doing so? The benefits of early and frequent feedback include avoiding requirements misunderstandings, which may not have been detected until later in the development cycle when they are more expensive to fix. Clarifying customer feature requests, making them available for customer use early. This way, the product better reflects what the customer wants. Discovering via continuous integration, isolating and resolving quality problems early. Providing information to the Agile team regarding its productivity and ability to deliver. Promoting consistent project momentum. 1.2 Aspects of Agile approaches. There are a number of Agile approaches in use by organizations. Common practices across most Agile organizations include collaborative user story creation, retrospectives, continuous integration and planning for each iteration as well as for overall release. This subsection describes some of the Agile approaches. 1.2.1 Agile Software Development Approaches. There are several Agile approaches, each of which implements the values and principles of the Agile manifesto in different ways. In this syllabus, 3 representatives of Agile approaches are considered: Extreme Programming (XP), Scrum, and Kanban. Extreme Programming. Extreme Programming (XP), originally introduced by Ned Beck, is an Agile approach to software development described by certain values, principles, and development practices. XP embraces 5 values to guide development: communication, simplicity, feedback, courage, and respect. XP describes a set of principles as additional guidelines: humanity, economics, mutual benefit, self-similarity, improvement, diversity, reflection, flow, opportunity, redundancy, failure, quality, baby steps, and accepted responsibility. XP describes 13 primary practices: sit together, whole team, informative workspace, energized work, pair programming, stories, weekly cycle, quarterly cycle, Slack, 10-minute build, continuous integration, test-first programming, and incremental design. Many of the Agile software development approaches in use today are influenced by XP and its values and principles. For example, Agile teams following Scrum often incorporate XP practices. Scrum. Scrum is an Agile management framework which contains the following constituent instruments and practices. Sprint. Scrum divides a project into iterations, called sprints, of fixed length, usually 2 to 4 weeks. Product increment. Each sprint results in a potentially releasable or shippable product, called an increment. Product backlog. The product owner manages a prioritized list of planned product items, called the product backlog. The product backlog evolves from sprint to sprint, called backlog refinement. Sprint backlog. At the start of each sprint, the Scrum team selects a set of highest priority items, called the sprint backlog, from the product backlog. Since the Scrum team, not the product owner, selects the items to be realized within the sprint, the selection is referred to as being on the pull principle rather than the push principle. Definition of done. To make sure that there is a potentially releasable product at each sprint's end, the Scrum team discusses and defines appropriate criteria for sprint completion. The discussion deepens the team's understanding of the backlog items and the product requirements. Time boxing. Only those tasks, requirements, or features that the team expects to finish within the sprint are part of the sprint backlog. If the development team cannot finish a task within a sprint, the associated product features are removed from the sprint, and the task is moved back into the product backlog. Time boxing applies not only to tasks, but in other situations, e.g., enforcing meeting start and end times. Transparency. The development team reports and updates sprint status on a daily basis at a meeting called the Daily Scrum. This makes the content and progress of the current sprint, including test results, visible to the team, management, and all interested parties. For example, the development team can show sprint status on a whiteboard. Scrum defines 3 roles. Scrum Master ensures that Scrum practices and rules are implemented and followed, and resolves any violations, resource issues, or other impediment that could prevent the team from following the practices and rules. This person is not the team lead, but a coach. Product Owner represents the customer and generates, maintains, and prioritizes the product backlog. This person is not the team lead. Development Team develop and test the product. The team is self-organized. There is no team lead. So the team makes the decisions. The team is also cross-functional. See section 2.3.2 and section 3.1.4. Scrum, as opposed to XP, does not dictate specific software development techniques, e.g., test-first programming. In addition, Scrum does not provide guidance on how testing has to be done in a Scrum project. Kanban. Kanban is a management approach that is sometimes used in Agile projects. The general objective is to visualize and optimize the flow of work within a value-added chain. Kanban utilizes 3 instruments. Kanban board. The value chain to be managed is visualized by a Kanban board. Each column shows a station, which is a set of related activities, e.g., development or testing. The items to be produced or tasks to be processed are symbolized by tickets moving from left to right across the board through the stations. Work in progress limit. The amount of parallel active tasks is strictly limited. This is controlled by the maximum number of tickets allowed for a station and/or globally for the board. Whenever a station has free capacity, the worker pulls a ticket from the predecessor station. Lead time. Kanban is used to optimize the continuous flow of tasks by minimizing the average lead time for the complete value stream. Kanban features some similarities to Scrum. In both frameworks, visualizing the active tasks, e.g., on a public whiteboard, provides transparency of content and progress of tasks. Tasks not yet scheduled are waiting in a backlog and moved onto the Kanban board as soon as there is new space production capacity available. Iterations or sprints are optional in Kanban. The Kanban process allows releasing its deliverables item by item, rather than as part of a release. Time boxing as a synchronizing mechanism, therefore, is optional, unlike in Scrum, which synchronizes all tasks within a sprint. 1.2.2 Collaborative User Story Creation. Poor specifications are often a major reason for project failure. Specification problems can result from the user's lack of insight into their true needs. Absence of a global vision for the system, redundant or contradictory features, and other miscommunications. In Agile development, user stories are written to capture requirements from the perspectives of developers, testers, and business representatives. In sequential development, this shared vision of a feature is accomplished through formal reviews after requirements are written. In Agile development, this shared vision is accomplished through frequent informal reviews while the requirements are being written. The user stories must address both functional and non-functional characteristics. Each story includes acceptance criteria for these characteristics. These criteria should be defined in collaboration between business representatives, developers, and testers. They provide developers and testers with an extended vision of the feature that business representatives will validate. An Agile team considers a task finished when a set of acceptance criteria have been satisfied. Typically, the tester's unique perspective will improve the user story by identifying missing details or non-functional requirements. A tester can contribute by asking business representatives open-ended questions about the user story, proposing ways to test the user story, and confirming the acceptance criteria. The collaborative authorship of the user story can use techniques such as brainstorming and mind mapping. The tester may use the INVEST technique, INVEST. Independent, negotiable, valuable, estimable, small, testable. According to the 3C concept, a user story is the conjunction of three elements. Card. The card is the physical media describing a user story. It identifies the requirement, its criticality, expected development and test duration, and the acceptance criteria for that story. The description has to be accurate, as it will be used in the product backlog. Conversation. The conversation explains how the software will be used. The conversation can be documented or verbal. Testers having a different point of view than developers and business representatives bring value input to the exchange of thoughts, opinions, and experiences. Conversation begins during the release planning phase and continues when the story is scheduled. Confirmation. The acceptance criteria discussed in the conversation are used to confirm that the user story is done. These acceptance criteria may span multiple user stories. Both positive and negative tests should be used to cover the criteria. During confirmation, various participants play the role of a tester. These can include developers as well as specialists focused on performance, security, interoperability, and other quality characteristics. To confirm a story as done, the defined acceptance criteria should be tested and shown to be satisfied. Agile teams vary in terms of how they document user stories. Regardless of the approach taken to document user stories, documentation should be concise, sufficient, and necessary. 1.2.3 Retrospectives. In Agile development, a retrospective is a meeting held at the end of each iteration to discuss what was successful, what could be improved, and how to incorporate the improvements and retain the successes in future iterations. Retrospectives cover topics such as the process, people, organizations, relationships, and tools. Regularly conducted retrospective meetings, when appropriate follow-up activities occur, are critical to self-organization and continual improvement of development and testing. Retrospectives can result in test-related improvement decisions focused on test effectiveness, test productivity, test case quality, and team satisfaction. They may also address the testability of the applications, user stories, features, or system interfaces. Root cause analysis of defects can drive testing and development improvements. In general, teams should implement only a few improvements per iteration. This allows for continuous improvement at a sustained pace. The time and organization of the retrospective depends on the particular Agile method followed. Business representatives and the team attend each retrospective as participants while the facilitator organizes and runs the meeting. In some cases, the teams may invite other participants to the meeting. Testers should play an important role in the retrospectives. Testers are part of the team and bring their unique perspective. IS2QB Foundational Level Syllabus, Section 1.5. Testing occurs in each sprint and vitally contributes to success. All team members, testers, and non-testers can provide input on both testing and non-testing activities. Retrospectives must occur within a professional environment characterized by mutual trust. The attributes of a successful retrospective are the same as those for any other review, as is discussed in the Foundational Level Syllabus, Section 3.2. 1.2.4 Continuous Integration. Delivery of a product increment requires reliable, working, integrated software at the end of every sprint. Continuous integration addresses this challenge by merging all changes made to the software and integrating all change components regularly, at least once a day. Configuration management, compilation, software build, deployment, and testing are wrapped into a single automated, repeatable process. Since developers integrate their work constantly, build constantly, and test constantly, defects in code are detected more quickly. Following the developer's coding, debugging, and check-in of code into a shared source code repository, a continuous integration process consists of the following automated activities. Static code analysis, executing static code analysis and reporting results. Compile, compiling and linking the code, generating the executable files. Unit test, executing the unit test, checking code coverage and reporting test results. Deploy, installing the build into a test environment. Integration test, executing the integration tests and reporting results. Report dashboard, posting the status of all these activities to a publicly visible location, or remailing status to the team. An automated build and test process takes place on a daily basis and detects integration errors early and quickly. Continuous integration allows Agile testers to run automated tests regularly, in some cases as part of the continuous integration process itself, and send quick feedback to the team on the quality of the code. These test results are visible to all team members, especially when automated reports are integrated into the process. Automated regression testing can be continuous throughout the iteration. Good automated regression tests cover as much functionality as possible, including user stories delivered in the previous iterations. Good coverage in the automated regression tests help support building and testing large integrated systems. When the regression testing is automated, the Agile testers are free to concentrate their manual testing on new features, implemented changes, and confirmation testing of defect fixes. In addition to automated tests, organizations using continuous integration typically use build tools to implement continuous quality control. In addition to running unit and integration tests, such tools can run additional static and dynamic tests, measure and profile performance, extract and format documentation from the source code, and facilitate manual quality assurance processes. This continuous application of quality control aims to improve the quality of the product as well as reduce the time taken to deliver it, by replacing the traditional practice of applying quality control after completing all developments. Build tools can be linked to automatic deployment tools, which can fetch the appropriate build from the continuous integration or build server and deploy it into one or more development, test, staging, or even production environments. This reduces the errors and delays associated with relying on specialized staff or programmers to install releases in these environments. Continuous integration can provide the following benefits. Allows earlier detection and easier root cause analysis of integration problems and conflicting changes. gives the development team regular feedback on whether the code is working, keeps the version of the software being tested within a day of the version being developed, reduces regression risk associated with developer code refactoring due to rapid retesting of the code base after each small set of changes, provides confidence that each day's development work is based on a solid foundation, makes progress toward the completion of the product increment visible, encouraging developers and testers, eliminates the schedule risks associated with Big Bang integration, provides constant availability of executable software throughout the sprint for testing, demonstration, or education purposes, reduces repetitive manual testing activities, provide quick feedback on decisions made to improve quality and tests. However, continuous integration is not without its risks and challenges. Continuous integration tools have to be introduced and maintained. The continuous integration process must be defined and established. Test automation requires additional resources and can be complex to establish. Throughout test coverage is essential to achieve automated testing advantages. Teams sometimes over-rely on unit tests and perform too little system and acceptance testing. Continuous integration requires the use of tools, including tools for testing, tools for automating the build process, and tools for version control. 1.2.5 Release and Iteration Planning. As mentioned in the foundation level syllabus, planning is an ongoing activity, and this is the case in Agile life cycles as well. For Agile life cycles, two kinds of planning occur: release planning and iteration planning. Release planning looks ahead to the release of a product, often a few months ahead of the start of a project. Release planning defines and redefines the product backlog and may involve refining larger user stories into a collection of smaller stories. Release planning provides the basis for a test approach and test plan spanning all iterations. Release plans are high level. In release planning, business representatives establish and prioritize the user stories for the release in collaboration with the team. See section 1.2.2. Based on these user stories, project and quality risks are identified and a high-level effort estimation is performed. See section 3.2. Testers are involved in release planning and especially add value in the following activities: defining testable user stories, including acceptance criteria, participating in project and quality risk analysis, estimating testing effort associated with the user stories, defining the necessary test levels, planning the testing for the release. After release planning is done, iteration planning for the first iteration starts. Iteration planning looks ahead to the end of a single iteration and is concerned with the iteration backlog. In iteration planning, the team selects user stories from the prioritized release backlog, elaborates the user stories, performs a risk analysis for the user stories, and estimates the work needed for each user story. If a user story is too vague and attempts to clarify it have failed, the team can refuse to accept it and use the next user story based on priority. The business representatives must answer the team's questions about each story, so the team can understand what they should implement and how to test each story. The number of stories selected is based on established team velocity and the estimated size of the selected user stories. After the contents of the iteration are finalized, the user stories are broken into tasks, which will be carried out by the appropriate team members. Testers are involved in iteration planning and especially add value in the following activities: participating in the detailed risk analysis of user stories, determining the testability of the user stories, creating acceptance tests for the user stories, breaking down user stories into tasks, particularly testing tasks, estimating testing effort for all testing tasks, identifying functional and non-functional aspects of the system to be tested, supporting and participating in test automation at multiple levels of testing. Release plans may change as the project proceeds, including changes to individual user stories in the product backlog. These changes may be triggered by internal or external factors. Internal factors include delivery capabilities, velocity, and technical issues. External factors include the discovery of new markets and opportunities, new competitors, or business threats that may change release objectives and/or target dates. In addition, iteration plans may change during an iteration. For example, a particular user story that was considered relatively simple during estimation might prove more complex than expected. These changes can be challenging for testers. Testers must understand the big picture of the release for test planning purposes, and they must have an adequate test basis and test oracle in each iteration for test development purposes, as discussed in the foundational level syllabus. Section 1.4. The required information must be available to the tester yearly, and yet change must be embraced according to Agile principles. This dilemma requires careful decisions about test strategies and test documentation. For more on Agile testing challenges, see Black 09 Chapter 12. Release and iteration planning should address test planning as well as planning for development activities. Particular test-related issues to address include the scope of testing, the extent of testing for those areas in scope, the test goals, and the reasons for these decisions, the team members who will carry out the test activities, the test environment and test data needed when they are needed, and whether any additions or changes to the test environment and/or data will occur prior to or during the project. The timing, sequencing, dependencies, and prerequisites for the functional and non-functional test activities, e.g., how frequently to run regression tests, which features depend on other features or test data, etc., including how the test activities relate to and depend on development activities. The project and quality risks to be addressed. See section 3.2.1. In addition, the larger team estimation effort should include consideration of the time and effort needed to complete the required testing activities. Chapter 1 ends.